right, I'm going to continue, and I'm still on day 1, but now we're going to discuss parabolas. The first bullet point here says that the parabola is the set of all fixed points in a plane equidistant from a fixed point called the focus and a fixed line called the directrix. So what I'm going to say is very important here. If you were trying your math space activities, you can skip anything that talks about the focus or the directrix. Okay, on math space, you can skip those. We're not going to get into those, and I know that some of the problems in the math space homework discuss that. You will not be penalized. Just skip over anything that says focus or directrix. Okay, we have discussed parabolas this year a little bit, and we're going to talk about 2 different types of parabolas. The first type of parabola that we're going to discuss is going to open up or down. Now, how we know that a parabola opens up or down is the x is the term that is squared. So if ever we notice that the x is the term that is squared, this is a parabola that opens up or down. Then we look at the number in front of x. If it's a positive number, it's going to open up. If it's a negative number, it's going to open down. Then we have parabolas that open left or right, and I actually have a typo on this page. So if you have printed this out, I would like for you to, underneath where I have this equation, let's rewrite this, and it should say x equals a, y minus k squared plus h. In the typed out version, the h and the k were actually reversed. Okay, so it should look like this. And how we know if something opens left or right is that the y is the term that's squared. So those are going to be like sideways parabolas. If the number in front of y is positive, it's going to open to the right. If this number in front of y is negative, it's going to open to the left. Now, when you graph them, we're not going to have to graph a lot with them. One thing you're always going to be asked is to find the vertex. So no matter what, we want to find the vertex. So to find the vertex, I'm always going to put it in what's called vertex form, which is this form right here for the x squared and this form right here for the y squared. That's what we're going to practice on this sheet. After we find the vertex, to help us graph the rest, there's a lot of different options in what we can do, and I'll show you as we go through some of the problems. So let's look down at problem number 1. And problem number 1 is a parabola, and I'm being asked for the vertex. So the x is squared. So I'm looking at this first box. I want to change this equation into something that looks like this so that I can pull off h comma k and have my vertex. To do that, I'm going to complete the square. Here's what we do. Y equals, I'm just recopying this, x squared minus 4x, and then I'm actually going to say plus blank because I'm going to complete the square with these x's. In this problem, I'm going to keep, for a parabola, I'm going to keep the 3 over here. Because if I notice my standard form, it just says y equals. That's the only thing on the left, the y. So I'm going to keep the 3 there. Now I can't just randomly add a number to my equation, so I'm going to just subtract it back out. That way it doesn't really change the equation at all. So just like in the last video, to figure out what number to complete the square, I take b and I cut it in half and I square it. Well, negative 4 cut in half is negative 2, and negative 2 squared is 4. So I'm going to add 4, and then I'll just subtract it right back out. The purpose of doing that is so that these factor. So y equals, this is going to factor into the same thing twice. If you watched the first video, the shortcut was it always factors into half of b. So b was negative 4. This is going to be x minus 2. Out here, I'm just going to combine these terms, and 3 minus 4 is negative 1. So this is the new equation that I'm going to be looking at. Once it's in this form, and what we call it is vertex form, I can pull off the vertex. The vertex is supposed to be h comma k. Well, inside the parentheses, anytime we're in the parentheses, we're going to take the opposite. So even though this says x minus 2, my x value is going to be positive 2. Out here on the end, my k value is just whatever I see here, so negative 1. Note, I only took the opposite when it was in parentheses. So there's my vertex. So if I come over to my graph and I plot my vertex, it is 2, negative 1. It's down here. And I know that this parabola is opening up. Okay, the way that I know it's opening up is it's x squared, so that means up or down, and in front of x is a 1. It happened to be a positive 1, so this parabola is going to open up. I only need 2 more points, and this is where you have some choices as to what you want to do to find those points. One thing you can do is you can try to find intercepts. So I can look for, and this might be the longer way, but I'm going to show you how in case you prefer this. I'm going to look for my y-intercept. Well, to find a y-intercept, I just go back to my equation. Now I can go back to my original equation or my newly written equation. I'm going to go to the original, and where I see x, I'm going to put in 0. That's how I always find a y-intercept. 0 squared minus 4 times 0 plus 3, I get 3. So my y-intercept is 0, 3. So 0, up 1, 2, 3. Now, parabolas are symmetric with respect to what we call the directrix, or symmetric right here, wherever the vertex is. So after I find that point, I could say, how did I get from the vertex up there? I went to the left 2, up 1, 2, 3, 4. That means I can also go to the right 2, up 1, 2, 3, 4. And I can connect the dots and be done. I can say, okay, I've got the vertex and 2 other points, which is what's going to be required of you. That's one way to do it. You could have, if you wanted to, also looked for x-intercepts. Okay, again, not needed. I'm just showing you all the options in example 1. The x-intercepts, I can go to my original problem, and where I see y, I put in 0. And I try to solve, and I recognize that this thing is going to factor into x minus 3, x minus 1, and so I get 3 and 1 as my x-intercept. So if I come on my graph, I could put an x-intercept at 1 and an x-intercept at 3, and that would be enough. Another way, and this is the way that I actually prefer because I think it's the easiest way to do it, is if you look up at your equation here, notice in front of the parentheses there's that a right there. Right here there's an a. If your a value is the number 1, so in my problem, my a value is 1. It was this thing right here. If it is 1, then you can go to your vertex and you can think of that just to find the first 2 points on either side, almost like a slope. And it's not a slope, but if the a value is 1, I can go up 1 over 1 from the vertex, up 1 to the left 1. And those are my 2 points. Okay, so again, to graph a parabola, we find our vertex. After the vertex, you can either use your y-intercept to help you, your x-intercepts to help you, or use the a value to help you. Let's jump down and look at example number 2. So example number 2, I am going to complete the square. So if I complete the square with this, I am going to factor, actually, you could complete the square, or this would be a prime example for using what we used earlier in the school year. And the reason I'm choosing not to complete the square, it will work, but there's a number in front of x squared, which makes completing the square a little bit harder. So instead of completing the square here, I'm going to use this formula, which you might remember from a month or so ago, that the x-coordinate of the vertex is negative b over 2a. So in this problem, my b value is negative 8. So my negative b would be positive 8 over 2, and my a is negative 2. 8 over negative 4, I get negative 2. So my vertex, my x-coordinate of my vertex is negative 2. My y-coordinate of the vertex, I need to go into my equation, and I need to find what y is when x is negative 2. So y is negative 2 times negative 2 squared minus 8 times negative 2 minus 5. Negative 2 squared is 4. 4 times negative 2 is negative 8. Plus 16 minus 5. Just keep simplifying. And I get 3. So my y-coordinate is 3. So if I come over to my graph and I'm going to plot negative 2, positive 3. That's my vertex. We never did discuss if this parabola is going to open up or down. And this particular parabola is going to open down because it is a negative x squared. And so because it's a negative x squared, it's going to be opening down. So I'm just kind of keeping that in mind as I go. My a value is not 1, so I can't use that shortcut. But if it's going to open down, I notice that it is going to cross over my y-axis. So let's try to find the y-intercept. So I'm just going to go into my equation, and where I see x, I'm going to put in 0. And I get -5. So that means I have 0, -5. 1, 2, 3, 4, 5. Now we did talk about in the first problem how these parabolas are symmetric. So there's my vertex. And if I went to the right 2, I was all the way down here at -5. Well, if I go to the left 2, I'm also going to be all the way down here. And I can just connect up my dots. And all we're going to require is that you have 3 points when you graph these parabolas, a vertex and 2 others. Okay. Example number 3 changes it up a little bit, because if you look at example number 3, the y value is squared, which means that it's a sideways opening parabola. And so it happens to be a positive y squared, and so it's going to open to the right. It's going to kind of look like a C when we graph it. So let's figure out what we can do with this. I'm going to complete the square. I'm going to choose to complete the square with this. So I'm going to say x equals y squared. I take that back. I'm not going to complete the square with this. There is no y value for me to complete the square with this. Instead of that, I am just going to pick the vertex off right away. If I zoom out a little bit and I go back to the top, remember the vertex is always h comma k, h being the number out here on the end, k being whatever is being added or subtracted here in the middle. So if I go back to this problem, my h value, see if I can get that focused, my h value is this number out here on the end, -2. K is whatever y plus or minus something squared. Well, y is not being added, and nothing's being added to y. So -2 comma 0 is going to be my vertex here. So if I come over to my graph and I go -2 comma 0, there's my vertex. I know that it's opening to the right, so I know that it's going to cross over this y-axis somewhere. And so I could find my y-intercept if I wanted to. I could all, well, let's find my y-intercept. Okay, if I find my y-intercept, I go in, and the rule is wherever I see x, I'm supposed to put in 0. So 0 equals y squared minus 2. And I could solve for y. So if I add 2, take the square root, don't forget plus or minus when you take the square root, and I get my y-intercepts are positive the square root of 2 and negative the square root of 2. Well, the square root of 2 is a little bit above 1. And negative the square root of 2 is a little bit below -1. And it's going to look like this. I could have also used that a value to help me in this if you didn't want to find the y-intercept. A is the number that's in front of the y squared, and it happens to be 1. So that means from my vertex, I could find a second point by going up 1 to the right 1, or down 1 to the right 1, right here. Those would be my points. Those would be okay as well. Okay, let's flip the paper over, and we've got a couple more parabolas that we want to practice. So example number 4. This is all nice in standard form for me. It happens to be a sideways parabola because the y is squared. This negative out front. That negative out front means it's going to open to the left. So we're just kind of keeping that in mind. It's going to look like this. My vertex is h comma k. H is this number that's sitting out here, -1. So -1. K is going to be the opposite of what's in parentheses, so -3. So let's come on to our graph. -1, 1, 2, 3, -3. I know that my parabola is opening to the left. I'm going to be able to graph this pretty quickly. My a value, this number in front here, it's -1, but the 1 value being the most important. To graph this from my vertex, I know it's opening left. I'm just going to go up 1 to the left 1. And down 1 to the left 1. And my parabola is going to look like this. All you need is a vertex and two other points. If that a value, which is the number in front of the y squared or the x squared, is 1 or -1, it's very easy to find your other points. You just simply go from your vertex, up one to the left, down one to the left, or depending whether your parabola opens up or down. Okay, looking at example 5, I'm noticing this one should be a quick one because my a value happens to be 1. So that's going to help me after I find my vertex. It's not in vertex form, so I do want to complete the square here. So I'm going to say x equals y squared minus 4y plus blank minus blank. When I complete the square, I take b and I take half of it, which is -2, and square it, which becomes 4. So I add 4 in, don't forget to subtract it back out. The purpose of completing the square is so that these three factor. They're going to factor into y minus 2 quantity squared minus 4. So that's the new equation I'm working with. This parabola is opening to the right. The y is squared, which means left and right. And it is a positive y squared. So that means it's going to open to the right. All right, my vertex, h, comma k. So my h is -4. My k is the opposite of what's in parentheses. Remember, we always take the opposite if something's in parentheses. So -4, comma, +2. Let's plot it. -4, +2. There's my vertex. And then my parabola is going to open to the right. So I can use the fact that their a value is 1. I can go up one to the right one, down one to the left one, or down one to the right one. Connect up my dots, and I'm going to have a sideways parabola. If you wanted to have more points, if you wanted to be more specific with this, you could find your y-intercepts. So I could have gone from the beginning and put in 0 for x. And if I want to solve that, I could factor a y out. And I get y equals 0, and I get y equals 4. So 0 and 4. Again, you don't need all those points. You only need the vertex and two others. All right, last example, example number 6. I'm going to complete the square with this. And this is a sideways parabola. It is opening to the right because it is a positive y squared. X equals y squared plus 4y plus blank. I have a +3 there, and now I'm going to subtract out a blank. To complete the square, I take b, which is 4, I cut it in half and square it. 4 cut in half is 2, 2 squared is 4. The purpose of complete the square is so that these first 3 terms can factor. It's always going to factor into the same thing twice. The shortcut is it's half of b, so if b was 4, it's y plus 2. On the end here, I'm going to combine these two. 3 minus 4 is -1. This is the new equation I'm working with. It's called vertex form. I can pull off my vertex. That's why it's called vertex form. H, comma, k. So in this case, my h is -1. My k, should it be 2 or -2? It should be -2 because it is the opposite of what's in the parentheses. So let's plot that point, -1, -2. I know that this parabola is opening to the right. I made that decision right from the beginning. And since it's opening to the right, my a value, the number in front of the y squared, is 1. So I can go up 1 over 1, down 1 over 1, and my parabola looks like this. Okay, I hope that this helped. There is on the next page some classwork practice. It is 8 problems, so things to work on. If you want some practice, you can work on the classwork. You can work on homework number 1, and you can work on the math space assignment. Those are 3 things that you can do this week to help you practice your circles and parabolas.